equals subset sum. Given an integer array nums, return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal, or else false. Or false otherwise. So 1, 5, 11, 5. So I think 1, 5, 5 versus 11. 1, 2, 3, 5. So you can do maybe 6 and 5. So you can't really do that. Alright, sums. So there's going to be 200 numbers. Each number is between 1 and 100 inclusive. Alright, pretty straightforward description. How to do that. How to do this. So I don't think you can just add numbers. So is this another backtracking? You can add a number. There has to be some other way besides. So backtracking means that you can add a number to a certain subset, to a certain half, and then when you hit the end, you see if the sums are the same. If they're not, then you backtrack and see and try a different route. But backtracking doesn't generally work when you have this many numbers. So yeah, this can't be backtracking. Backtracking generally traveled through every single route. This would be 2 to 200 routes. So if you try to do an optimization where for each number you put it to the side that is smaller, that doesn't work either, I don't think, because then you still need to test it going to the bigger side. You can partition the two subsets into sums such that the sum of the elements. So again, it could be one side is the biggest item, and then all the other things are actually on the smaller side. So what you could do, I feel like you should probably try sorting, because even if it costs you to sort, the numbers are so small that it doesn't really matter. Or the length of the array is so small it doesn't really matter. Like this is definitely, if you can do this in n squared, this doesn't run very long, like 200 times 200 operations. I feel like if this is a really fast algorithm, then you should be able to do this on like a 1,000 or a million, and it doesn't really matter. So it's not linear. No, there's no way. It's probably quadratic. So if it's, so once you have it sorted, so 1, 5, 5, 11. You can do something where, well, 1, 2, 3, 5. Put the biggest number on one side, and then 1, 2, 3, 5. Add the 1, the 2, and get 3. Or you take the 1 and the 2 and split them and get 1, get negative 1 as the difference. Oh, okay. So you add elements to 2. Can you try adding both elements? Try adding to both sides. So for any given element, you can either add it or subtract it from the current current 2 to the power of 200. So for instance, let's say you just kept a track of the difference, right? The difference between the two partitions. So if you have 1, then the difference is automatically going to be either, and let's say you calculate the difference as, so we have a difference variable, where the difference is track difference between two partitions. So the difference is either going to be 1 or -1. If you add 1 to the first partition, to the first half, so this P1 minus P2, partition 1 minus partition 2, so it's either going to be +1 or -1, depending on whether or not you put the 1 in partition 1 or 1 in partition 2 after that point. So 1, 5, 5, 11, it could be 1 diff values, it could be 1 or -1, and then if you do 5, then it could be like 6. You can add 5 to the 1, or subtract 5 from the 1, add 5 to the -1, or subtract 5 to the -1. And then similarly for 11, you can get 11, or for 5 again, 11, 1, adding 5 to the -4 is going to be 1, or -9, adding 4, -9, adding 5 to 4 is 9, -1, -1, or -11. Okay, those are all the possibilities. Is that? And then obviously if you have 11, then it cancels there. I wonder if that's reasonable. I wonder if that's reasonable. Again, the numbers can be ending up to be very large. I think maybe if I sort in reverse order, start with actually the largest numbers, and then have a prefix sum as well, and not do anything that's too big, not go too big. Okay, so I sort the numbers, and then I'll have a prefix sum. Let's say I take the total numbers. Actually, it will be kind of like a postfix sum. Postfix sum array, and this is tracks sum of all remaining values in the array. That's like the idea would be if I go backwards, if I go 11, 5, 5, 1, and the postfix sum is going to be like guess you could include 11 plus 5. 11 plus, so it'd be 22, 11, 22, 11, 6, and 1. So if you go 11 and you try to go to 16 by adding 11 and 5, you know that because the remaining values are just 6 and 1, the sum of the remaining values 6 and 1, then 16 is just not possible, because then even if you subtract all the remaining values. So it gives an upper bound as to how high the sums should go. So postfix sum, so for every value in nums, I'll do postfix to append the total for post append, actually append total, and then total minus this value. I'll print out the postfix just to make sure that this is working. So 11's 22, 11, 6 and 1, 11, 6, 3, 1. Okay. So that's the postfix sum. And I think what I'll do is I'll do the set of possible differences. Track set of all possible differences. And I'll have a set which will only be 0. And then I'll have for every value in my nums array, I'll say next set is going to be we'll be going through the current set and either adding or subtracting it. So for every diff in the set of differences currently, if the difference plus the value is, let's say max diff, there also should be a way to, like, all these things are kind of duplicated. Is there a way to get rid of certain duplications? So if I just kept the positive numbers, does that make sense? I don't think so. I still need to have negative numbers. Alright, whatever. The maximum difference is going to be maximum difference at this point. I think I need to go through these for every index in range n being the length of numbers, and then the value is the index, the value is the nums at that index. The maximum difference is the postfix at this index. So if the difference is greater, I could even say if the difference is equal to the maximum difference. So you could reach a point where just the current sum this max difference is done later. So maybe you shouldn't include the current index value in the postfix calculation. Like I'm thinking if you have 11 and you're comparing it with 11, hopefully you can identify that you should just subtract all the remaining values. So say if value equals max diff, then return true. Okay. And then otherwise, if difference plus this value, yeah, maybe you should include the current index. You should only include the index after it. So maybe postfix needs to start with 0. So it would be like 0, 11, no, 0, 22, 11, 6, 1. And then if you add 11, but then why would you compare it with 22 at that point? Maybe it should be this. Maybe it should be 11, 6. No. 11. So total minus 11. So 11 minus 6 would be 6. Minus 5 would be 6. Minus 5 would be 1, 0. So not inclusive of the current thing. So maximum difference. So not including the current value. So postfix this thing. For difference in set, if 0 plus 11 equals the maximum difference remaining, then return true. Else if it's bigger than the maximum difference, then don't do that. Else next set add difference plus value. This could be still too small. Else if the okay, that's fine actually. And then if difference minus value is too small, less than the negative of the maximum difference. Less than or equal to, I guess. Then continue. Else next set should add a difference minus the value. And then set differences is equal to the next set. And if none of this works, then return false. Alright, let's see how slow this is. So work on that one, didn't work on this one. So let's go ahead and print out the set difference after each iteration. That difference is just okay, let's put it out here, I guess. First let us set 0. Each difference in the set difference. So it starts with 0. And then either add the value or subtract the value. 0, the value should be value should be 11. So 11 plus 0 should be difference plus value. Should be 11. And that should equal the maximum difference at that point. Oh, maximum difference is initially 0. Oh, I need to get rid of that. Maximum difference, I screwed up setting it to be 0. Okay, yep. Okay, let's get rid of print. Okay, so let's print this again. Let's go over the nums. So the sum of everything that is like 984 through 2 is 26. Okay, so I add 14 and negative 14. So there's 17. Okay, and then the next thing is the maximum difference of these things is 17. So I do add 9, or if I add 9 to that, there's no way that that's possible. Or subtract 9 from this is not possible, so it has to be subtract 9. Has to be subtract 9 from 14. What happened to the positive 5 here? The difference minus the value is smaller than or equal to the maximum difference. So I can't add difference. So the difference is negative 14. For instance, negative 14 plus 9. So let's print out the value and the maximum difference. Alright, so the value here is 9, the maximum difference is 17. So with negative 14, I should be able to add 9. Negative 14 plus 9 is fine. And for the 14, I should be able to subtract 9. The difference, 14 minus 9 is 5. 5 is less than 17 minus 9. What is the difference minus the value? So if the difference plus the values equal to the max measurement, that's going to be subtracting all the variable values. Return true. It's too big, and return, then don't add it at all. Else, add the difference plus the value. Difference minus the value. So that should have added, yeah, it should be negative 14 plus 9. Should give you negative 5. And if the difference is 14 minus the value of 9 is 14 minus 9 is positive 5. Positive 5 is smaller than or equal to the negative maximum difference. Yeah, why does that add 5? 14 minus 9 is smaller, it's not less than or to negative 17. Considerations that are, should say negative 5 and positive 5. Difference, so we have, oh whoops, there should be a difference plus value. So it's considering negative 5 and 23. Oh, it should not be continuous, it should just be if the difference plus the values is equal to or less than. Continual would just skip over the second part. And then this part you can continue, sure. Okay. Alright. So that worked. Alright. Is there a way to somehow do half of this work? Because I'm doing the full set of all possible things, both positive and negative. Is there a way to limit just to be strictly positive in some way? I don't think so. So, tracking differences, either add or subtract. Add too much and you don't subtract too much. So, time you have a difference, you can add the positive or the negative of the difference. And you can just work on the difference plus the value, I think. So what if I tried if the difference plus the value is equal to, it's fine. If it's less than, then add this, and the next set to add the negative diffs. Difference. No, but then you still need to be able to subtract. So you're adding but is subtraction not just the same thing as the addition of a negative version at some point? Okay, maybe this might work. Oops, I don't want to test this. Maybe this works. Okay. Alright, that was a little bit of speed bump. What was it, 340? Yeah. What if you had for each difference plus the value equals the max difference? Otherwise, if it's possible, then add both the positive and negative and move on. What if you just wonder if you could wonder if you could somehow determine if 0 is part of the set. Yes. No, 0 being part of the set just means you went all the way to the end. I wonder if you could maybe have 2 heaps where let's say you arbitrarily have 2 partitions and the partitions remove one element from partition and you add it to the other partition. Doesn't seem to work. I don't think that works. Alright, I think this is still pretty reasonable. It explores all the possible differences, but in a somewhat bounded way. Alright, oh, I'm printing the nums. Maybe that's actually slowing things down. Not particularly. Okay. Alright, well, I think this is decently constructed solution. So I'll go with it. So summary, this is sort the, after sorting the array, create a postfix array that is the sum of all values after each index, which can bound the calculations for each index. So track the possible differences in partitions starting as a set starting with 0. So for each number you either add it to partition 1, in which case the difference goes up by that value, or subtract it from partition 1, or put it in partition 2 where you have the negative of that value as a difference. And for each value, either difference increases or every difference in possible set increases or decreases by that value. That occurs like here. With the bound that constraint that the new difference must be less than the sum of all remaining values. So if there's ever a chance that difference plus that value makes it so that even if you subtract all the remaining values in the nums array, you don't get back to 0, then don't even try it. If at any point maximum difference or difference plus value is equal to 0, then return true, because then you're just subtracting all the remaining values. If never break, then awesome. Alright, this is going to be time complexity of, this is O of n times, I think this is O of n squared, I want to say. Because for each number, maybe n cubed? Actually, let me think about that. So for each number, you have the possible differences between that number and the previous numbers. That's a hard calculation. So this might be O of n times O of, how many differences could the set of differences go to? Yeah, so I'm not sure actually where O of n is your array values and O of question mark is the most differences in your set of differences. So your differences grows possibly by 2 each time, but I don't think it's 2 to the power of n. I guess it's bounded. So maybe O of n squared. Space complexity This again is O question mark. I'm not sure how many differences, depending on how many differences. And O of n for the postfix array. All right. Sir, please improve production. Your solutions are helping. Oh, I'm not sure how I should be improving it. If you have any suggestions,